Hello everyone. In this video, I will discuss one example of synthesis of passive network. The example one shows the construct the circuit diagram for following LC impedance function using the first of all. This is the our impedance function. ZLC is equal to 4 times S squared plus 1 times S squared plus 16 over S into S squared plus 4. Before construct the circuit, we have to check whether this function is realizable for synthesis uh, to develop a network. To verify the realizable, there are some properties. These are the general properties for passive RLC function. It says it must be a rational function with S with real coefficient. May not have poles or zeros in the right half S plane. May not have multiple poles or zeros in the j omega axis. That means imaginary axis. May not have the degree of the numerator and denominator differing by more than 1. And must have a non-negative real part for all S equals j omega. And the last one is must have positive and real residues for poles on the j omega axis. And there are some additional properties for LC network. First, as the first step, I will check whether this function is realizable or not. For that one, first I will find the roots of the numerator and the denominator. If we consider the numerator, roots are s is equal plus or minus j and s is equal plus or minus 4j. These are the roots of the numerator and these are the zeros of the function. And then I will consider the denominator. Roots are s is equal 0 and s is equal plus or minus 2j. And these are the poles of the given function. Then I draw the poles and zeros in the complex S plane. This is imaginary axis and this is real axis. Zeros at plus j and minus j. Next one plus 4j and minus 4j. This is minus 1 plus 1 plus 4 and poles at the 0 at the origin and plus 2 and minus 2j. These are the poles. There are 3 poles and 4 zeros. Now I will move to the properties. The first one says must be a rational function in S with real coefficient. It is a rational function with coefficient of S. And then first property is okay. Then the second property says may not have also or zeros in the right half S plane. In that one, this is the right half plane. You can see there are no any poles or zeros in this right half S plane. Then second property is satisfied. Then third one is may not have multiple poles or zeros on the j omega axis. Here there are 4 zeros and 3 poles. Multiple poles means if assume if we have another zeros with s equal plus or minus j, it is S1 is equal plus or minus j and S2 is equal plus or minus j. These are the multiple pole, sorry, multiple zeros. In here, there are no any multiple zeros or poles. Then third condition is satisfied. And the fourth one is may not have the degree of the numerator and denominator differing by more than 1. When we consider this function, the maximum degree of the numerator is 4 and the denominator maximum degree is 3. Difference is 4 minus 3 is equal to 1. Then may not have the degree of the numerator and denominator differing more than 1. It is satisfied. Then the fifth one is must have a non-negative real part for all s equal j omega. Now I will write the function again. Say del c s is equal to, I expand this function s to the power 4 plus 17 s squared plus 16. In the denominator, s to the power 3 plus 4 into s. Now I will assign s is equal j omega. S is equal j omega. J omega is 4 times j omega 4 plus 17 j omega square plus 16 j omega cube plus 4 into j omega. 4 times j omega, sorry, 4 times omega 4 minus 17 omega squared plus 16, and the denominator is j into minus omega 3 plus 4 omega. This is the function when I assign the s is equal j omega. If I consider the real part of this ZLC, you can see the denominator is the imaginary part. Then the real part of this function is 0. Then the fifth property says must have a non-negative real part for all s equal j omega. Real part is 0, is non-negative. Then that condition is satisfied. And the last one is sixth one, must have a positive and real residue for poles on the j omega axis. For that one, we have to do the partial fraction expansion for this function. In this function, the degree of the numerator is greater than the degree of the denominator. Then partial fraction expansion, we can Right, 4 times is 4 plus 17 s squared plus 16 s cube plus 4 into s. We can write a into s plus b into s cs plus d over squared plus 4. These are the, we can s into s squared plus 4. Then I multiply both sides by this. Then 4 into s4 plus 17 s squared plus 16 is equal to s time s cube plus 4s plus b into s squared plus 4 plus s into cs plus d. Now we have to find a, value of a, value of b, value of c and d. For that one, first I consider the s to the power 4 factors. For left hand side, 4 is equal to, from the right hand side, it is a. A is equal to 4. Then I consider s to the power 3. There are no any s to the power 3 terms in both sides. Then I consider s to the power 2. From the left hand side, 4 into 17. And from the right hand side, 4a plus, from this one 4a, from this b plus, from this one c. 17 into 4, 68, and a is equal to 4, then 16 plus b plus c. B plus c is equal to 52. Then I consider s to the power 1. From this side, there are no any value. From the right hand side, it is equal to d. The value of d is equal to 0. Then I consider this to the power 0. From the left hand side, 4 into 16 is equal to, from the right hand side, 4 into b. B is equal to 60. From this one, 16 plus c is equal to 52. C is equal to 36. And these are the values. C is equal to 36, B is equal to 16, and A is equal to 4, and D is equal to 0. Now I can rewrite the partial fraction expansion. Z del CS is equal to 4 times S plus 16 over S plus 36 S over squared plus 4. This is the expansion of the impedance function. Then in the sixth property says must have positive and real residues for all poles on the j omega axis. Poles are related to these values. Residues means these values 36 and 16 and 36. Both of are greater than 0 and real. The property says positive and real residues for poles. Then the sixth condition also satisfied. And let's move to the additional properties of passive LC driving point function. The first one is function must be a ratio of even odd or odd even polynomials. In this function, the numerator degree is 4, maximum degree is 4, and the denominator maximum degree is 3. 3 over 4. It is a odd, 4 over 3. S to the power 4 over S to the power 3 maximum degree. This is even over odd. It is satisfied. And second one is poles and zeros lie on the imaginary axis and are simple. You can see poles and zeros, all poles and zeros are lie on imaginary axis and all are simple. Then second condition also satisfied. And third property says the highest power of the numerator and the denominator should differ by unity. The highest power of the numerator is x to the power 4 and the highest power of the denominator is x to the power 3. The difference is 4 minus 3 is equal to 1. Then it is okay if we consider the lowest power in the numerator, the lowest power is x to the power 0, x to the power 0, and in the denominator, lowest power is x to the power 1. This is highest, this is low. The difference is 1 minus 0 is equal to 1. Then both the conditions are satisfied. And the fourth property, there must be a pole or 0 at the origin and infinity. You can see there will be a pole in the origin. Then fourth property is okay. And the last property is the poles and zeros are alternate. That means in this imaginary axis, start with origin, start with the pole, then again 0, pole, 0. That is the alternate option. Alternate 1, pole, 0, pole, again 0. You can see poles and zeros are alternate. Then all conditions are satisfied. Then let's move to the realization of the, construction of the circuit. I will write the partial fraction expansion again. ZLC is equal to 4s plus 16 over s plus 36s over s squared plus 4. For each section, we can represent impedance value. This is Z1, Z2, and Z3. This is ZLC means the total impedance, and these are the small pieces of impedance value. If I consider the Z1 is equal to 4s, and if we consider impedance value of an inductor, we can write it as in S plane Ls. Then Z1 will be a inductor. Value is 4 Henry. It is an inductor with the value of 4 Henry. And when I consider the Z2, it is 16 over S, and I rearrange it to 1 over 16 into S. If we consider the capacitor, the ZC is, we can represent 1 over CS. Then Z2 is a capacitor with the value of 1 over 16 farad. 1 over 16 farad. Now these two are okay. This is the inductor, this is a capacitor. Now I consider the Z3 component. That part, that impedance, 36 S over S squared plus 4. Now I consider the admittance value of it. Admittance value means 1 over impedance value. 1 over Z3. It is equal to S squared plus 4 over 36. I rewrite that one again, S over 36. So 36 S plus 1 over 9S. And these are two admittance value, YA and YB. If we consider the admittance value of inductor, YL, we can write 1 over LS. And admittance value of a capacitor, YC, we can write CS. Then according to that one, if I consider the YA, this is over 36. I can rewrite it again 1 over 36 into S. It is more like to a capacitor. 1 over 36 is the capacitor value. Write it as C2 is 1 over 36. And then I will consider the YB. It is 1 over 9S. It is more like to this representation. That means inductor. The value is 9 Henry. And the combination of these two components are the total admittance. That means Y3. The combination is mentioned plus mark. In admittance values, plus mark mean it has a parallel connection. Then we can draw inductor plus capacitor for Y3. This is Y3. The capacitor is 1 over 36 and the inductor is 9 Henry. Then for the representation of Z3, we can draw a parallel connected capacitor and inductor. This is 1 over 36. This is 9. If I consider the total impedance Z3, we can get the same this answer. in a parallel connection, Z is a capacitor and inductor. Impedance of the capacitor multiplied by impedance of the inductor over impedance of the capacitor plus impedance of the inductor. Here, impedance of the capacitor is 36 S multiplied by 9, sorry, for this one, 36 into 1 over S into 9 over S. This is the impedance of the inductor and this is the impedance of the capacitor over 36 multiply 1 over S plus 9S. For the numerator, we can write 36 into 9 over the denominator 36 plus 9S squared over S. We can write this one 36 into 9S over 36 plus 9S squared. Now 9 will cancel out. We can write 36S over S squared plus 4. We can get the same answer for Z3. If you want to verify this circuit, this component is Z3 obtained by this process. In this one, first I consider the admittance value and break into two parts and construct that component. Then I prove that construction is correct by calculating the impedance value. Then when we consider total impedance, it is the combination of Z1, Z2 and Z3. Z1 is the inductor, Z2 is the capacitor, and Z3 is the parallelly connected capacitor and inductor. In here, it is mentioned as plus, that means series connected. Then we can draw the final circuit. This is Z1, Z2, and Z3. From here, we can get the total impedance ZLC. L1 is equal to 4 Henry. C1 is equal to 1 over 16 farad. C2 is equal to 1 over 36 farad. And L2 is equal to 9 Henry. This is the final circuit for this function. This LC impedance function. I will repeat the process again. First, I verified it is a realizable function by checking the properties of passive RLC function. Then check whether it is compatible with the additional properties, and I use the partial fraction expansion to expand the impedance function. Then I found out each Z1, Z2, and Z3 components, and finally I combine those components and construct the final circuit. That is the process of synthesis of passive network using a first of all. It is mainly based on the partial fraction expansion of a impedance function. I hope you understand about this process, and thank you.